Welcome to this case study on ORC generator, synchronous or asynchronous. We are quite familiar with the operation of a thermal power plant. In thermal power plant, water is converted into heat, and with the help of thermodynamic process, that is Rankine cycle, this heat is converted into mechanical work, and thereby we get a electrical energy with the help of an alternator. The operating fluid in the case in thermal power plant is water, and water is heated to a very high temperature. You may have a question in your mind whether is it possible to generate power from low temperature fluid also. Yes, it is possible, and that is achieved with the help of organic Rankine cycle. Similar to Rankine cycle, it is also a thermodynamic cycle to convert a low temperature heat into mechanical work. The only difference is operating fluid. The operating fluid here is an organic fluid. It is not water, it is organic fluid. So organic fluids such as isobutane, propane, pentane, etc. can be used for organic Rankine cycle. You would have heard about CHP systems, cogeneration power plants with the help of biomass, geothermal, solar, and heat recovery systems. All this use organic Rankine cycle. You may wonder whether the generator that is fitted with the ORC turbines, is it a synchronous generator or asynchronous generator? We'll just have a discussion whether it is synchronous or asynchronous. If it is going to be synchronous, the operating temperature of the fluid is very less. So the mechanical work also it is going to be very less. Therefore, the alternators are going to be driven at very low speed. That is one issue. And the performance of the synchronous generator is going to vary based on the type of load that is going to be connected. And you have a lot of synchronization procedures to couple the generated power with the grid. If it is going to be a synchronous generator, again, issue with this speed of operation. And second thing is asynchronous generators need to be operated at a very high speed. It is above synchronous speed, slightly above the synchronous speed. And if it is going to be a generator, then you need to have regulation units to establish the RMF initially. All those issues are there. And the output power that is going to be generated out of a asynchronous generator is going to be of low power factor. If a synchronous generator is being used, if it is going to be used, even though the power output is going to be very low, it can be amplified. It can be amplified with the help of power electronic interface circuits. So low output power of ORC generator can be amplified to a higher level. That is possible with the help of power electronic interface circuits. And you can try to achieve a high power factor also with power factor correction circuits. If it is going to be a asynchronous generator, then you need to use capacitor bank arrangement, right, at the output. That is also there. As a manufacturer, the manufacturer should look for three conditions. They should adhere to the electrical regulations of the electricity board. They should think about the quality of power also, and they should aim for a seamless integration of power with the grid. All those three aspects have to be considered. In the case of asynchronous generator, the capacity of capacitor bank that has to be used has to be calculated, and the switching arrangement that is necessary has to be decided, and you need to have a very tight band to maintain the speed of operation above the synchronous speed. So all those criteria have to be considered. If it is going to be synchronous or asynchronous, the manufacturers have to think about the financial binding also. So they have to clearly work out the cost, right? Cost of all the main circuits as well as the auxiliary units. And as a user, I would recommend for a synchronous generator because you can obtain power, seamless output power, right, with a synchronous generator from ORC, right? Thank you.